transcript don't even get their last prime time ever because they're gone. They're supposed to. I have seniors, and so my seniors that left this morning that are my prime time, seniors are supposed to give advice for underclassmen, and my seniors gave very terrible advice. Like, don't ever take calculus. That was advice. Don't try because you're not going to get scholarships anyway, so who cares? They're very bitter right now.
Who gave that one?
Well, a couple people, and then other people like chimed up and were like, they were like, yeah, that's true. Like they're very upset about life. Tyler Vandermark's like ready to give up on college because he didn't do scholarships. Very sad. And he says he can go to Vincent's and get a 2-year degree and make the same money as going to Purdue and getting a 4-year degree. So why even care? So then we got in the big discussion of money makes you happy. Write this down.
It helps share your world with us.
I'm with you. There's more to life than money, but you know, money pays the bills. So.
Money lets you do everything in life.
You know what helps? Bills, not having bills to pay.
Right, if you live in that kind of world. Kids take money, so. So then Cora told us how her dad lit money on fire to show them that money wasn't important. It was a bill at least. I think it's hard to light a quarter on fire.
I think it's illegal.
Yeah, I'm pretty sure it's illegal.
Don't tell Cora's dad.
Because you have to keep track of stuff and apply there. It's like,
Yeah, it's illegal to burn it up.
I will look it up. It's illegal.
It's illegal.
It's my property. You can't unburn the money. You can like tape up a dollar bill. You can't unburn it.
What if it's shredded on accident?
What if it's shredded on accident like a lot?
What if the dog ate the money?
Wait a couple hours.
But most people aren't going to burn money. I don't think they really prosecute over that.
Chris McCann was third.
Right. Did you write this down yet?
From the government.
You can burn flags.
Nope.
Yeah, you can. That's protest.
It's protest.
So maybe I want to burn money in a protest.
It's different. They have to keep track of that.
We need to ask Mr. Rhodes.
We did. We had the court case. Yeah.
Not burning money. I'm burning flags.
I know. I want to know about burning money.
No, it's not illegal. It is.
Call it.
Right now. Give him a rating. Come on.
It's private.
He has nobody in class. He really does. Give him a rating. He's not doing anything.
If you have two complex numbers in trig form, so I called this Z1, so notice I have R sub 1, cosine theta sub 1, plus I sine theta plus 1, sub 1. And then I have Z2, it's the same thing, I just called them sub 2s. If you want to multiply two trig forms of a complex number, you multiply the R's, you add the thetas. You gotta know that. I don't like the flashing hands. Is everyone absent in here on the field trip?
Yeah.
Katie, on the
I
field
don't
trip?
know if Spears was saying that. Steven's on the field trip. I don't know. Short's on the field trip. Short's.
Ellen's on the field trip. Is she in that class? Okay. We're good.
Yes.
Okay, I just
So is Steven.
think.
Told her already. Yes, shut up.
We can prove this. I know you don't care about proof, but my class I'm taking, I've been learning lots about proof, and I like to share it with you. You can prove this by doing the sum identities that we learned last chapter. So remember, like if you had cosine, you can say this cosine of theta 1 times sine of theta 2. No, it's cosine, cosine, cosine.
What?
Cosine, sine.
I think so.
It's cosine, cosine.
I'm so confused on what you're saying.
Just write this down. You remember when we did that? Like, cosine of u plus v is equal to cosine of u times cosine of v minus sine of u sine of
Yes,
v.
we're good at that.
That's what I'm saying we could do here. I was just having a moment of remembering. We could prove that this works out right if you did that. I know you don't care about proof.
We care. We just don't.
You don't.
We just will.
If you divide complex numbers in trig form, you divide the r's, but you subtract the thetas.
We just want to learn the least amount we can.
Yeah, that's true. That's why we don't ever retain our knowledge, because you don't understand where it comes from, and so that's why you forget it right away.
You're recording, so.
I don't care. I can be grumpy on the recording. I don't mind. They're not going to listen to it. Like maybe 3 people.
I'm confused.
0.
You're underestimating this. I watched like one or two.
Dylan watches some.
So like in terms of success,
0. I don't care if people watch them. I do it so that when people say I was absent, I don't know how to do the homework, I can say, did you watch the video? And they can say no, and I say, watch the video, then come back and see me.
I did the.
That's why I do it.
I was like,
Watch the not watch.
you really don't.
I do the yes.
Well, are you mature? What are the brackets? Oh, the brackets are just like extra parentheses.
Right, you can just make big parentheses if you want, kids. I just went brackets. It's just another type of grouping symbol. Don't freak out. Some awesome fractions I made there, right?
Yeah, I like those. How'd you get the pie raise?
Oh, I don't know. I think I did like a superscript. I've spent way too much time making.
Sign to the power of
So
five.
look, this is separate. Oh no, that's all together. So I did like superscript and then I underlined it and then I went and put the numbers under it.
I thought it took some thought.
It takes a lot of effort. It was before I used to have this button I wrote this question.
I think the 12 should be decided.
They probably are. But now I have this awesome button that I could just do this and I could just type a fraction. And it's much better than I could just type pi 12ths. But yeah, I think it doesn't show as much creativity as I do. If you know the formulas, this is really easy, especially if it's already in trig form. If you multiply, what do we do with the r's? We multiply them. So we're going to take 2 times 6. I'm going to show this because it's our notes. I'm going to take 2 times 6. And then what am I going to do with the thetas? Add them.
Let's try your
On test or even on your homework, you don't have to show this step, but I just think it's smart sometimes in your notes to show how did you get that answer, because if you just look back at the answer, then you have no clue where it came from and you don't have to do your homework. But then we just simplify this, and yes, you can have your calculator, you don't even have to think. But pi fourths, if we change that to 12ths, that would be 3 pi 12ths. So 3 pi 12ths plus 1 pi 12ths is 4 pi 12ths, which is...
By thirds. I meant by thirds.
It says give trig form, so is that the answer? Is that the trig form?
Yes. No, wait, no.
Yes.
It is.
Trig form has trig in it.
What's the other form called again? With the a plus pi?
Standard form. In my Math 137 class, which is a class that you can get dual credit for in here, the book does something weird that I've never seen before in my life, and I really don't want you to do it, but I'm going to show you anyway, because I think it's crazy. I just want to show you, like, I read the book, and I thought, like, am I so old that I don't know this new notation? And so I went and asked Mr. Allspell, have you ever seen this before? He's like, no, that's the dumbest thing I've ever seen. And I'm like, I know.
You didn't bother asking Spy or Mr. Wentworth?
No.
Wow.
They say, because these angles will always be the same, they shorten it, and they write this as CIS for cosine, I, sine. CIS is not anything. Like, that's just made up letters.
Those are, there's definitely a real letter of I, just I.
It's a made up trig thing. 12 cis pi thirds.
It looks like N should be N CIS. I like it.
Anyway, that's the notation that's in the Math 137.
I feel like that's not too bad. Yeah, but see,
I like this.
But just add things to your way.
Oh, look, I'm missing what we divide this by.
Better do everything. Come on, Grady.
No such thing as too much letters.
I could just make up something here. Let's divide this by, good thing I didn't print these out for you.
What's happening right now?
I just forgot to put what you divide by.
Oh, you're so lost.
Good news is I think we're going to be able to fit in chapter 8.
Yeah. Oh, that's good.
Wait, so we have another chapter after this one?
We do!
Guys, you better start learning slow.
Chapter 7 ending?
No, we're skipping chapter 7.
We just get rid of Nope. Can't we just start tonight?
Yeah, let's spend 19 days studying for our final. That's the dumbest thing I've ever
That
heard.
would be good. We don't need to learn so much. Ensure that like we got A's. All get A's.
Yeah, okay, fine.
I am a fan. We would all get A's if you know that.
No, you wouldn't, because say that's 1/4, and we subtract the thetas. So 5 pi thirds minus pi 6. And I'm just going to put because I know it's going to be the same thing, and I'll write it out in a minute when I get my final answer. That would be 10 pi 6, yes? Minus 1 pi 6. It's 9 pi 6.
Yep,
3 pi halves. I don't know why I put that in parentheses, but whatever. That's not bad, right? Oh,
They're gonna get worse.
it says give standard form, which means this is I'm not done yet, right?
I don't know.
No, you put a box too late, kick it out.
Standard form is A plus BI. So if you have trig form, how do you go to standard form? You just multiply it out. So what is the cosine of 3 pi halves? 0. Cosine is x, so on the y-axis, that's 0. What is the sine of 3 pi halves? -1. So 1/4 times 0, still 0. 1/4 times -1 would be -1/4 I, or -I over 4, if you prefer.
That's it. That's the standard form.
If the angle that you get here is not from the unit circle, like on number 18, you just use your calculator and get a decimal. So sometimes you're going to have ugly decimal answers. Okay? One more thing.
The example
Not
was
one
a
more
lot
slide.
worse on your paper. That's all.
No, that's tomorrow.
Oh man, I was really.
De Moivre's
glimpse of
theorem.
hope. What is that?
De Moivre. Yes.
Maybe you should
De Moivre.
say it. Is that okay?
Alright, so I have a question. About their, are we not gonna have like a day in class where it's review? Is that what that?
It's the same language. French Italian.
Abraham De Moivre died 1754.
See, assassin.
Also made major contributions to the field of probability. De Moivre's theorem says if you have a trig form of a complex number, and if n is a positive integer, then there's a shortcut to taking this to the nth power. So it should make sense. Just like when we multiply the r's. When we divide the r's. If we're going to take this to the nth power, we are going to take r to the nth power, but we're going to just multiply n times theta. That's your formula. You need to know that. And then we're just going to practice working it out.
Will this work for anything else you've done on here? Just this.
Has to be a complex number. So remember when we did Pascal's triangle stuff?
Yes.
We had some imaginary numbers in there. So if you had 3 plus 4i to the 10th power, one option is you write it 10 times and FOIL it all out. Barf. One option is you go to the 11th row of Pascal's triangle and you get the coefficients and then you do all the counting down. Remember that? No?
Yeah, that was semester.
That was last semester.
Okay, that one.
But another option is if you can change this to trig form, which we did yesterday, where you find r and theta, you can also use this formula to do that. So I think that's a shorter way. Read the directions. Sometimes it's going to say leave it in trig form, which means you just work it out and you leave the angles there. Sometimes it's going to say write in standard form, which means you just work it out. But the big thing is, in order to use De Moivre's theorem, you have to put it in trig form first. So that's why we practiced that yesterday. So before I can take this to the 10th power, I need to write it in the r cosine theta plus I sine of theta. Well, you go ahead and start FOILing out 10 times. Oh. So this means that A is -1, B is 1, so R is going to be square root of 2, right? Square root of 1 plus 1. Yes?
That gives us 1 squared, -1 squared, plus 1 squared.
again, think about what quadrant you're in so you make sure that you give me the right angle to start with. If A is -1 and R is +1, I'm over here in quadrant 2. And again, if it's from the unit circle, sometimes you can just think about it. If it's, I kind of made that too long there. If this side is 1 and this side is 1, and the radius is radical 2, what angle am I at over there in quadrant 2? 3/4, right? 1, 1, radical 2? If not, then just work it out. Sine, cosine, tangent. I don't know which one you want. Sine would be V over R, or radical 2 over 2. If you're using inverse sine on your calculator, it's going to tell you pi-4, or 45 degrees. And you have to know that you're in quadrant 2. So sketch it out. Think about where you are. But I think that we should say this is 3/4. Yes? We did this on our homework yesterday? So I'm going to say that this is R, which is the square root of 2, times cosine of 3/4 plus I sine of 3/4, and I'm going to take that to the 10th power. Yes? Now I just use the theorem. The theorem says I take R to that power, so I'm going to take square root of 2 to the 10th power, and what do I do with the angles?
Multiply the 10 by the...
10 times 3/4.
Do you have to write that step that you wrote above on the comparison?
No. So square root of 2 to the 10th works out really nicely, but what if you didn't have a calculator, or what if it was square root of 2 to the 9th and I didn't want you to give me a decimal? I want you to be able to think through that. So a reminder about exponent rules. A square root is the same as what power? It's like a 1/2 power, right? So the reason when you type this in your calculator that it equals 32, there's a couple ways to think about it, but if you think about it as a fraction, half of the answer already. Half of 10 is 5, so that's why 2 to the 5th is 32. Also, you could think about, just like we talked about, the reason that the square root of 3 squared is just 3, every time you have 2 square roots together, it's going to work out nicely. If you have an odd power here, it just means you're going to have an extra square root of 2 left over. And so just kind of think about that as you're doing these, try to give me nice answers. This, what does this work out to be? 15 pi halves. Is that right? Ten times 3/4. Everybody with me on where I'm getting these values from? I don't think the directions say that you have to give answers between 0 and 2 pi. So if it said leave in trig form, you could leave it like this. 15 pi halves is just a whole lot of times around the circle, which means you could change it to the, keep subtracting 2 pi till you get an angle between 0 and 2 pi as well. But if it said leave it in trig form, like that's an okay answer. But if it says standard form, then you just have to work it out. And again, if it's a nice answer, if it's from the unit circle, I do want those answers. The nice thing about halves is that their calculator is going to give you the nice answer anyway. Where is 15 pi halves? What is that? 7.5, right? Yeah, I think it's 3 pi halves. So you could just keep subtracting 2 pi, or I like to just think about 2 pi, 4 pi, 6 pi, 7.5 pi. Like that's the same as 3 pi halves. So that would be times 0. And the sine of 3 pi halves is -1. Which means if you work that out to the 10th power, boiling it out 10 times or using Pascal's triangle, you would end up with just -32i. How do you feel about that? Overjoyed? Ecstatic? Let's do another one. I want to do one like this just because they throw this in every now and again, and I just want to remind you, this is to the 3rd power. So am I allowed allowed to just multiply that 4 in there? No, because you really would have to work that out 3 times and then multiply the 4. So the 4 kind of just hangs out front till the end, mostly just waiting for you to forget about it and mess it up, right? Like it's a trick question, I think. So the 4 is just going to hang out here, but we're going to do the other part the same way that we did. And maybe you would say, I wouldn't do De Moivre's theorem. I could do Pascal's triangle quicker on this, and it's just the third power. Maybe you could. But the worst part about De Moivre's theorem is putting it in trig form. So I'm just going to keep the 4 here, hang out. A is 1, B is negative radical 3, which means R is what? 2. 1 plus 3 is 4. So the square root of 4 is 2.
I was just saying 1 is great.
And then we got to find theta. And again, hopefully you kind of are seeing that we have a square root of 3, we have 2, we have a 1, right? That's a 30, 60, 90 triangle, which means it's going to be a nice angle. What quadrant am I in this time? A is positive, B is negative. 4. So that means I'm down here. So you can draw the triangle if you want, but just know you're in quadrant 4. So if you, I tend to use sine all the time. Sine is B over R, so that would be negative radical 3 over 2 in quadrant 4, 5/3, is that right? Yes? No? Yes. 5/3. Because the sixth side is 1/2, right? So that means this is 5/3. You got to be able to do that, or use your calculator and convert it to a nice radian. What's you going to radians? So I can say cosine of 5/3 plus I sine of 5/3, and then I'm going to take that to the third power. The 4 does not go to the third power. The 4 is just out front. We're going to multiply it by 4. Questions on where I'm getting that? Well, because we changed A and B into sine and cosine, and so you're never going to have a negative in between here. Does that make sense? Like it's always going to be, the negative is what told us our angles in quadrant 4. Okay? So now using the theorem, keep my 4 there, I'm going to get 2 to the third times cosine of 3 times 5/3. Is that just 5 pi? 2 to the third is 8. 8 times 4 is 32. 32 seems to be a theme of ours. It doesn't say here whether to leave it in trig or standard form, so we're just going to go standard form just so you can practice that. But this would be the trig form. You leave the trig in it. Standard form is you work it out in the a plus bi. And again, 5 pi is really nice. That's just over there where pi is. So the cosine of 5 pi is negative 1. The sine of 5 pi is 0. Which means if you work that out, like you get a real number. Turn into a real number. They're not all 32 or negative 32 or 32i. Like this one just happened, and the last one just happened to work out like that. Questions about that? Tomorrow it gets a little uglier. Maybe you think this is ugly, but this is kind of not that bad to do. Tomorrow there's a lot longer problems. Like you only have 4 problems on your homework tomorrow, I think. Because there's a bit more work to do. I might have had another problem, but it's 5 times, so. Oh, I didn't. 6, day 2. 7 problems. The first ones are multiplying and dividing, which really aren't that bad. And they say find the trig form, so that's really nice. 24 is not bad. And then 31, 32, and 35, those are De Moivre's theorem. So this is our last examples. These were our first examples. So not that bad to do. Make sure you're doing this, because tomorrow it's like we're adding one more step to this of how to find roots of a problem using this stuff. So it's kind of all building on itself. And then tomorrow's last day of new stuff for Chapter 6. Review on Thursday, test on Friday. Try to be here, all right? Because next week AP exams start, and it's just going to be a big mess. So